Hello, my name is Brianna Bennard. This summer, I had the opportunity to work at Pratt & Whitney's Materials Control Laboratory and assisted in sample acceptance testing. One of the major issues that arises in the lab has to do with human error. When one metallurgist analyzes a sample, the sample is declared passing or failing based on his or her decision. He or she is then responsible for that specific sample and decision, so in the future no one else can inspect the sample and come to a different conclusion. This causes disagreements and uncertainty. It is very important to eliminate human error in the sample acceptance process as much as possible because all production stops until the sample is analyzed. If the sample passes, production may continue as planned, but if the sample fails, production cannot continue for the day until measures are taken to fix the issue. I was asked to create a decision support system that decides if a sample is within tolerance and if it passes or fails inspection. This would discourage employees from flipping through binders to look for correct customer specifications and making mistakes, as well as save time, money, and materials. On the samples worksheet of the decision support system, there is a shop floor layout with 3 different types of machines and the pedestrian paths along the floor. There are also 2 passing sample inventory locations and 2 failing. The user begins by selecting the Analyze Sample button to input information about the specific sample they are analyzing. To view the access connection, we go to Queries and Connections, and we can see that there is a table with a column for each sample type, the lower and upper tensile strength bounds, as well as the spray thickness specification. Once the user analyzes the sample, they need to take that sample and store it in the correct inventory location. The user clicks the Optimize Inventory Route button, and the system animates the optimal route by determining how long the specific sample needs to be stored based on the sample type and whether it passed or failed. Each arrow is considered 1 unit, and the number of arrows are summed to find the shortest length. The user is shown the shortest route, and a message box appears telling the user the shortest distance as well as how long the sample must be stored in the specific location. When the user is done relocating the sample to inventory, he or she can click the Reset button to get rid of the current route so it is ready to calculate the optimal route of the next sample. So if the user selects Analyze Sample, Product 2, Part 1, and Machine A2, we can input the tensile strength of 50 and spray thickness of 0.12. When we analyze the data, we see that this sample has passed. So we can close out of the user form and optimize the inventory route for this sample. We see that the optimal route to inventory for a passing sample from machine A2 is of length 10. This sample must remain in inventory for 1 year before being disposed of. So we can see the inventory route from A2 to the nearest passing inventory location. We can reset this inventory route and analyze another sample. We can test the same type of sample, Product 2, Part 1, but on machine B2, and input the same measurements for tensile strength and spray thickness. We see that this sample fails. It should have a tensile strength between 58 and 61. We can optimize this inventory route, and we see that this sample must be stored for 2 years before being disposed of and has a length of 7. We can see the shortest route from machine B2 to the closest failed sample inventory location. Then, the user clicks the Analyze Sample Data button and is taken to another worksheet. On the analysis worksheet, the user clicks Sample Statistics and specifies the sample information, then puts in the population size for that type of sample that day and the sample size that the sample was taken from. The tensile strength average, spray thickness average, standard deviation, and max and min are calculated for this sample type. Now I will explain the VBA code. To analyze a sample, tab strips are used on the user form to allow the user to go through and input all of the necessary information. At the top of the code, when the button is clicked to analyze the user input, the code checks to make sure that the user inputs numeric values for tensile strength and spray thickness. If the user does not input a numeric value, there is a message box that directs the user to enter valid input. Then there are loops reading the specs for every combination of product type, part type, and machine number from Access, bringing the specs into a hidden worksheet and checking the specified sample. To simulate and optimize the inventory route, oval nodes were created and named along the pedestrian path, equal distances from each other. Arrows were also named and the length specified so they are all 1 unit long. Then if statements are used to simulate the optimal route for each part type at each machine to the nearest passing or failing sample inventory. The number of arrows is counted and a message box appears to tell the user the shortest length. To clear the arrows from the current inventory route, a home node was created and each arrow is sent back to the home node. At the beginning of the sample acceptance process, after the user inputs the sample information on the first user form, the user is instructed to click Save Data before continuing to analyze the sample. This saves the user input to the end of a list in a hidden worksheet. Each time the user inputs data, the values are added to the end of this list for calculations. The first analysis user form requires the user to select the specific type of sample. The second asks for the population and sample size for that specific day. The user clicks Calculate, and it calculates the average, standard deviation, maximum and minimum values for tensile strength and spray thickness. This decision support system will help the lab workers to efficiently analyze all types of samples to keep production moving throughout the day. It will also provide accurate results and help eliminate human error that comes with sample acceptance. Each employee will have their own system to save only their sample statistics. This is very important because they become responsible for their collected samples, and if there are any issues in the future, they will be able to go back and look at the data. Thank you for watching.